Good evening, Bearcats. Tonight we're going to start Laws of Sine, which is Chapter 6 in Section 1. We're going to move from the world of right triangles to the world of oblique triangles, which means a triangle that has no right angle. We need at least one side and any two other parts to be able to use the laws of sine. All right, we're going to go ahead and review a little bit about laws of sine, and we'll do some examples. Here's a triangle with angle A, C, and B, or A, B, and C. And of course, the side opposite A would be side A, noted by a small letter, lowercase a. Lowercase b denotes side B, and lowercase c denotes side C. And the capital letters, of course, the angle measures. This breaks down into four cases when we are talking about oblique triangles. We can have two angles and any side, which would be our angle side, or our angle side angle. This is all from geometry. We could have two sides and an angle opposite one of them, which would be side angle. And then we could have three sides, which would be all three sides, which would be your A, B, and C. Or we could have two sides and their included angle, which would be side, angle, side. So there are four cases. The first two cases can be solved using the laws of sine, which is what we're going to work on this evening, whereas the last two cases require the law of cosine. And we will talk about that tomorrow. Okay, let's move on. All right, the laws of sine are noted by the following information. We can use our formulas, and if we have this triangle ABC, and it has sides lowercase a, b, and c, then we can use side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Now, you're going to use two of these at a time. We're not going to use all three at once. And the reciprocals can also be used, which is the one I use probably the most often, which is the angle over the side. Notice that the angle and the side have to be a pair for you to use this. Here's an example of how we do that. You may want to stop the video for a minute and take a note and draw this picture so that you have both an acute triangle and an example of an obtuse triangle labeled. That might be good reference for you, especially when we move a little bit further along. But let's just take a look at this example using the laws of sine. All right, so example, we have angle A is 123 degrees, angle B 41 degrees, and side A is 10 and side C is what we're missing. So we have an angle, what I call it angle side pair. So we can say angle A are the sine of A over side A, and if we want to find C, we're going to need sine C over C. All right, look what we have. We have two angles of a triangle. We can find our missing angle by subtracting from 180, since all triangles add up to 180. So 180 minus 123 minus 41 would give us 16 degrees. So side C, angle C, angle C would be 16 degrees. So now we can plug in our information. So sine of 123 over side, which is 10A, equals sine of angle C, which is 16, over C, which is our missing angle. And then we're just going to cross multiply and solve. So we would have C times sine 123 degrees equals 10 times sine 16 degrees. To solve for C, we would divide away, so we'd have side C equals 10 times sine 16 degrees divided by sine of 123 degrees. And if we put that in our calculator, we're going to get, let me move this over here, that side C is approximately 3.29. 3.29. And we don't have a unit measure here, so we don't really know what that is. All right, let's move on. In this example, we have a triangular plot of land that has an interior angles of 95 and angle C of 68 degrees. If the sides between the angles are 115 yards, what are the lengths of the other two sides? I'm going to draw a picture here. So we have this plot of land, and I'm just going to draw. Often I draw the same triangle and I don't really pay attention to it being to scale. If that bothers you, you may draw a more accurate picture. I'm just going to label this side A, B, and C. And you'll see in my examples I use the same triangle over and over again. And I rely on what I put, the measurements I put on the picture, not necessarily the scale drawing. All right, so angle A is 95 degrees. Angle C is 68 degrees. We don't know angle B. And the side between these two angles is 115. So I've labeled my picture. We want to know the lengths of the other two sides. So we basically want to know little c and little a. Well, we can find our capital B, our angle B, by subtracting from 180. So 180 minus 95 minus 68 is going to give us 17 degrees. So this is 17 degrees. Now we have a side angle pair because we have the 17 degrees matched up with 115 degrees, or 115 yard side. Couple of things just from geometry to remind yourself of. The largest angle across from the largest angle should be your largest side. The across from the smallest angle should be your smallest side. And if that's true, it's just kind of a mental check to make sure you're doing things correctly. When we find A, it should be much larger than B. And when we find C, it should be somewhere between A and B. So just keeping that in mind. All right, let's go ahead and set up our laws of sine. So we have sine 17 degrees over 115 equals sine, and we'll do A first, of 95 degrees over side A. Again, cross multiplying, so we're going to get A times sine 17 degrees equals 115 times sine 95. To solve for A, we'll have 115 times sine 95 degrees divided by the sine of 17 degrees. And when we do that in our calculator, we'll get A is approximately 391.84 yards. All right, so let's go ahead and put our unit of measure there. Yards. That makes sense, since that's the largest side. It's much larger than side across from B. All right, now let's go ahead and find side C. So this was approximately 391.84 yards. Let's find C. We can use the same given information as before, so we would have sine 17 over 115 equals sine, and this time, since we want C, we have to use 68. 68 degrees over C. Again, cross multiplying, C times sine 17 degrees equals 115 times sine 68 degrees. Solving for C, 115 times sine 68 degrees divided by sine of 17 degrees. When we put that in the calculator, our C value will be approximately 364.69. So 364.69. There's our C. There's our A. That would also be in yards, and that would also make sense since 68 degrees is much larger than 17, then 364 is much larger than 115. However, it's not as large as side A, which would be across from the largest angle. All right, that was a lot to absorb. You might want to pause, think through what we just did, and using the laws of sine before we go on to the next. So I might pause and take a look. Next, I want to introduce to you something called the ambiguous case. Ambiguous means we're not quite clear because of the information that we've been given. So if we're given two sides and one opposite angle, then we have three situations that it could occur. We could have no triangle because the third side might not be long enough to complete the triangle. We could have one triangle, which is in most of our cases, or we could have two triangles. And this can occur in specific situations. I want you to look at the next slide that I've just copied out of your textbook, and I want you to write this down and think about what each of these mean. Think about what each of these mean. I'm going to give you a few minutes. I would pause it, and then I'm going to give you a little hint that sometimes, or most often, is helpful. It's not 100% foolproof, but most often it is helpful. One of my little hints for you is and this, like I said, this isn't 100%, but often I'm going to, if the opposite side, so if the opposite, I'm going to abbreviate, side from the angle I'm looking for is less than the adjacent side, then I have a special case. And that would be no triangle or two triangles. Okay. We're going to take a look at several examples that'll make this a little more clear, but I just wanted you to have that, to keep that in mind. That's kind of a hint for you to keep that in mind. It especially will help you when there are two triangles, because that one is most often overlooked. You'll find one triangle and then you'll forget that there could be another combination. All right, again though, pay really careful attention to this information from the book on ambiguous cases, and also pay attention to the difference between acute triangles and then your obtuse triangles. All right, in our next example, we're going to be given side A is 26 degrees, B is 5 feet, and A is 21 feet. Let's just kind of do a little sketch. Again, like I said, I am not doing a scale sketch. I'm just kind of doing my A, my B, and my C triangle. A is 26, B is 5, and C is 21. Remember what I just said. I just said that if the opposite side from the angle, all right, if the opposite side from the angle, which would be 21, is less than the adjacent side, which it is not, it is greater than the adjacent side, then there would be a special case. But because A is actually greater than B, then there's only going to be one triangle. So in this case, there should be one triangle. All right, let's find out the missing information. So let's find out angle B. So to do that, we have a side angle compare we can use. So we can say sine 26 degrees over 21 equals sine B over 5. Cross multiplying, you get 5 sine 26 degrees equals 21 times sine B. All right, in this case, you cannot just divide, well, you can divide away 21, and you'll have sine B equals 5 sine 26 divided by 21. I flip-flopped as well. Sorry about that. I should have moved them the other side. To solve for an angle, and remember this before, to solve for an angle, you can't divide by sine. You have to multiply by the inverse. So angle B, I'm going to put a little angle sign, B is going to be approximately equivalent to the inverse sine of 5 sine 26 over 21. All right, and you'll put that in your calculator, and B will be approximately 5.99 degrees. From there, if this is 5.99 degrees, you could subtract the 5.99 and the 26. I'll do that. 180 minus 5.99 minus 26, and find that C, angle C, then is approximately 148.01, which it certainly doesn't look like it in my drawing. All right, 148.01. And now we have information about angle C. We can find side C. So we would set up and say sine 26 over 21 equals sine 148.01 over 21. Again, you would cross multiply and solve, oops, not over 21, over C. Sorry about that. Over C. Cross multiply and solve, and when we do, we would find C to be approximately 25.38. 25.38. All right, let's look at another example. All right, here's another example. I just drew my basic triangle again. It says B is 78 degrees, and side C would be 12, and side B would be 5. Again, the angle opposite is less than the angle adjacent. And remember, we said if the angle opposite is less than the angle adjacent, we will have a special case. So we're either going to have no triangle or two triangles. So let's see what the case is here and how we would know that. All right, so the first thing we're going to do is we're going to find angle C. So we're going to have sine 78 degrees over 5 equals sine C over 12. Cross multiply, and we'll go 5 times sine C. You always multiply to the missing side first. That makes the math a little, or makes the process a little easier. Equals 12 times sine 78 degrees. We would divide by 5, and then we want to find C. So we have to take the inverse. So C would be inverse sine, or arc sine, 12 sine 78 degrees over 5. When we put that in the calculator, all of a sudden you're going to get an error message. Alert, alert, alert. An error message. And that is because no triangle exists. No triangle exists. All right, go Bearcats. All right, for the next triangle, we're given that A is 29 degrees, and B, side B is 10, and side A is 6. Okay, the side opposite, again, is less than the side adjacent, so we either have no triangle or two triangles. All right, let's go ahead and plug in. Now, there's information here about H, just kind of giving you a hint. Go back and look at that ambiguous case diagram that you wrote down and take a look at H and A and B and see how that relates back to that ambiguous case. I think that's going to be really, really important for you. So these are all ambiguous if you have a side, and an angle. And we have two sides and an angle. All right, and the angle's not in between the two sides. All right, here we go. So the next thing we're going to do is we're going to set up our angle side pair. Sine 29 degrees over 6 equals, we're going to find angle B, so sine B over 10. Cross multiply, so 6 sine B equals 10 sine 29. Divide by 6, and then we're going to solve for B. So B is going to be the inverse sine, or arc sine, 10 sine 29 over 6. All right, this time we actually find the value of B to be approximately 53.9. Woohoo! We're excited. So, but here's where you had to pay attention. Because this side was smaller than the adjacent side, then you have to be really careful. This could be 53.9. But since we did, oh, sorry, B could be 53.9. Let me erase the other. Put my triangle back there. Oh, I'm messing that up. I need to go back. There we go. Put my triangle back in here. Sorry. All right, so 53.9 is angle B. Because though the side originally opposite was smaller than the other, we either have no or two triangles, most likely in the ambiguous case. The reason is because we don't know what angle C is. So this could be 53.9. Sorry, I'm not doing very good with this new marker. 53.9. Or take 180 and subtract 53.9. When you do, you're going to get 126.1. So this angle could also be 126.1. You want to double check to make sure that this is a good angle. And to do that, you need to make sure that 126.1 plus the angle that you already know you have, which was 29, you want to make sure that that is less than 180 degrees. You just want to make sure that that is less than 180 degrees. And in this case, that would be less than 180 degrees. Let's see, we would have 0.1, and 9 and 6 would be 5. 1, that'd be 4, 5, and 1, I believe. Let's see. No, that's not right. 9, 5, carry 1. Yeah, 55. 26, 36, 46. Yeah, that's right. So 155 point. And because 155.1 is less than 180, that still gives us an alternate angle for C. So in this case, now that we know that B could be 155.1 or B could be 53.9, then we have two other possibilities for C. So angle C could be, if it was 53.9, then you would take 180. And you would subtract the 29 that you were given, and you would subtract your 53.9. And you would get C was approximately 97.1. Or angle C, if your angle B was 155.1, you would take the 180, subtract the 29, and subtract the 155.1, and not 155.1. Sorry, 126.1. Sorry about that. You would take your 180, subtract your 29, and subtract your 126.1, and find that angle C was approximately 24.9. And you would have to use the two values for C to figure out which one that was. All right, go Bearcats. Okay, finally tonight I want to talk about the area of an oblique triangle. This is going to be using the area formula for sine. We also have another area formula we'll talk about tomorrow. The area of any triangle that is 1/2 the product of the length of the two sides times the sine of their included angle looks like this. Let's talk about this example. This is just a formula that you'll need to know. Again, you would only be using one of these formulas. You're not going to be using all three of them. So either it would be for sine A, sine C, or sine B, depending on what information. It really has to do with that the angle is included. So the angle is between the other two sides. The angle is between the other two sides. So let's take a look at this picture. I'm just going to again draw my normal A, B, C triangle. This says B is 143, which is obviously not this picture. Sorry about that. And this says A is 7 and C is 18. So we have the side angle in between the two sides, so you can use this formula. So your area would be 1/2 side B, or sorry, well, you wouldn't use B. This would be like A and C, right? So it would be this one right here. So it would be 18 times 7 times the sine value of the angle in between them, 143. You just put that in your calculator and you would find the area to be approximately 37.91, and since these were meters, we'd say meters squared since it's an area measure. Okay, so you're just plugging in. The formulas aren't as important as you realize that the sine value has to be the angle between the other two sides. That's what's really important about this. All right, the last thing I want you to write down this example in your notes, and I want you to use the laws of sine to find this answer, and I want you to circle it, and I want you to write "Go Bearcats" by your answer, and I want you to show this to me when you come to class tomorrow, and I will give you credit for that and know that you've watched the video. All right, I hope you have a good night, and go Bearcats!